Hi again. All right, so we're going to work through example number 1. Now in the first one, it says, what is the enthalpy change for the formation of 2 moles of nitrogen monoxide from its elements? So we are given a target equation. This is what we want to know. Now the reality is we don't always have nitrogen and oxygen out there to make up nitrogen monoxide. So what we can do is look at other reactions or known equations where we know the enthalpy and use those to combine to figure out what we're going to do to find out this target reaction. So we need nitrogen, we need oxygen to make our 2 moles of nitrogen monoxide. So things that we know. So we're given, these will be provided. We are given two pieces of information. We know the creation of nitrogen dioxide, and we know another way to make nitrogen dioxide. So what we need to think about is how can we manipulate these two equations in order to get the substances that we want for reactants and for products to find out the target enthalpy. So to do that, we simply need to take a look at what we need. We need nitrogen. We have it in equation 1. We're going to need an oxygen. We have it here as well. But that's not making what we want. We want this. This is our target product. So we also have this given equation. So what we'll see where we have duplicates of the nitrogen dioxide. So we want those to cancel out. We don't want those. They're not in our target. The same thing with oxygen. We don't want twice. We need the right amount. So what we're going to look at is manipulating them. So what we can do is this. Let's look at the first equation. In equation number 1, we only have half a mole of nitrogen gas. We want a full mole. We want 1 full mole. So to do that, we simply have to multiply the first equation by 2. So that gives us 1, because we're multiplying a half by 2. So this one is going to be multiplied by 2. So we're going to end up with 1 mole of this, 2 moles of oxygen, because we started with 1 here, and 2 moles of this, because we had 1 here. So in doubling that, notice that we also double our enthalpy value. Now, in equation number 2, we're going to do the same thing here, but in this case, we're not only needing to double it, because what we need to think about is we need 2 moles of nitrogen monoxide. We only have 1 here. So we need to multiply this by 2. But not only that, we also don't want it in this order. We need the reverse, because we ultimately need this nitrogen dioxide to be canceled out. So what we do is we multiply it not by 2, but by -2. If we multiply it by -2, that will actually flip it completely. So now the nitrogen dioxide is multiplied by 2, and it is now a reactant. This is multiplied by 2, and it is now a product. And this one we also multiply by 2, and now we have 2 nitrogen monoxides. That will also multiply this by a -2. So whatever we do to the equation also happens to the value. I don't know if you had my little typo there, but make sure you have a negative in front of that. So once we have that, now we simply are going to add these equations together. We're going to add them. So first things first, we take a look at what's going to cancel. We have 2 of those and 2 of those on either side of the reaction. They will cancel out. Now, I only have 1 oxygen here. I have 2 there. So this will cancel out, and 1 of those will cancel out, leaving me with 1. So now what I can consider is what is left over. Well, there's my nitrogen. I'm going to move this up so you can see my target. Okay, so I have my nitrogen gas, and then I have 1 oxygen here, plus 1 oxygen gas. Everything else is canceled out. On my product side, this is canceled, that is canceled, leaving me with only NO2 or NO1 gas. And now I have my exact target reaction. To figure out the delta H, I'm going to do the same thing. So I'm going to add these 2. So my delta H of my target is simply 2 times 34 kilojoules plus a -2 times -56 kilojoules. And now you simply have to do the math that goes along with that. And if we do that, we are adding in 68 kilojoules, kilojoules plus 112, sorry, that should be a K, not a bracket, kilojoules, for a total of 180 kilojoules. That is my target enthalpy. And we use the subscript, sorry, you can't see it, target, to show our final answer. So the summation of that, again, this is what we call Hess's law. Okay, this is example number 2. What is the enthalpy of change for the formation of 1 mole of butane from its elements? So again, we very rarely make butane from its actual elements. But what we do know are a lot of other things about methane. It's combustion, so here's the combustion of it. We know how carbon dioxide is formed. We also know how water is formed. And we also know the enthalpy values for all 3 of these. So using what we know, we can actually find a target to find out what it would produce should we have pure carbon and hydrogen to work with. So to do that, we need to look at what we have and what we need. So we need to consider the manipulation of each of these equations. So in the first one, I always take a look at what we have and what we need. So here's our carbon, and there's our carbon. What we need to think about here is we actually need 4 carbons, not the one that we have. So we're going to multiply this by 4. It's on the correct side of the equation, so I don't have to reverse. My hydrogen, on the other hand, I have 2 hydrogens here. Don't have anything else anywhere else, so 2, and I have 5. So to accomplish that, here come my fractions, I need to actually multiply by 5 over 2 so that I have 5, okay? So I need 5 overall, so that will multiply, 2's will cancel, give me 5 hydrogens. Now over here, this one is fine, it's 1 mole, and I have 1 mole, but it's on the opposite side of the equation. So what I need to do is I need to actually flip it. So I'm going to multiply this one by -1. So now I know how I'm going to manipulate my equation. So let's do the altering now. So in flipping them around, I'm going to take equation number 1, and now I have to flip it. So I'm going to have 4 carbon dioxide plus 5 H2O. We're going to produce C4H10 plus 13 over 2 oxygens. All right, now my delta H value, I'll worry about that in a moment, but I need to multiply that by -1 as well. So I'll come back to that piece. Now, in equation number 2, I now have 4 carbons, because I'm multiplying 4 by everything, plus 4 oxygen. That gives me 4 carbon dioxide. And again, my delta H, I'm going to multiply by 4. Down here, multiplying the fractions through, that will give me my 5 hydrogens that I need. It'll give me 5 over 2 oxygens, and that'll produce 5 water, gas, and in this time I'm going to have a delta H multiplied by 5 over 2. So now let's make sure we get this final equation by adding them together. Now it always helps to have different colors. Colors are always a wonderful thing. So I like to look at what I need. I need this, so I always circle it so I can keep track of what I'm looking for. This is what one I need too, and I also need this. Now, if I have done it correctly, everything else should cancel out. If it doesn't, I've made an error along the way. So taking a look at this, my 5 waters cancel out nicely. Then the 4 carbon dioxide also cancel out nicely. Now, taking a look, I have 13 of these, 5 over 2, or 13 over 2, and 5 over 2. Well, 4 over 2 is simply 8 over 2. Adding these 2 up, sure enough, there is my 13. 8 plus 5 is 13 over 2, so that cancels. Everything else is canceled, leaving me with my target reaction, with the correct coefficients balanced. Now it's time to figure out the enthalpies. Now that I know that I've manipulated them properly, I can use my equations. Oh, the lights went out. Hold on. When you sit in a classroom long enough, the lights go out. Okay, where was I? So, once I have all this looked after, what I'm going to do is I'm going to add my enthalpies. So my delta H of the target is number 1, which is, I'm going to write that, so negative of my delta H1, then it's 4 times my delta H of 2, and then it's 5 over 2 times my delta H for number 3. So in adding those together, doing my math properly, I have a negative 2657.4 kilojoules plus 4 times negative 393.5 kilojoules plus 5 over 2 times negative 483, and these values were all given in the initial question. Doing the math all together, carefully entering your negatives and your positives, you'll see that overall it is an exothermic reaction with a magnitude of negative 125.6 kilojoules for the total enthalpy of my target reaction. That's Hess's law. Your textbook goes through some great examples. It's very easy to follow. Your supply teacher will give you the textbook pages. I'd like you to try example number 3 together at the bottom of your page, and I'd like you to compare your answers with a partner and then with other people around you to see how you make up tackling it on your own. It should all work out. Don't you love it when math is so neat and tidy with a nice little bow? I should have tied a little bow. Anyway, love you guys. Woo-hoo. Okay, see you tomorrow.